Okay, this is problem number 103, section 2.4 of the calculus book. And if you turn, this is on page 139, you'll have to turn to look at the problem because if I write it out, I won't have any room to work it. It says a 15 centimeter pendulum moves according to the equation theta equal 0.2 cosine 8t, where theta is the angular displacement. Just going to put this DISPLA for displacement from the vertical axis, from the y-axis in radians, and t is the time in seconds, so that's how many seconds has passed. Determine the maximum angular displacement and the rate of change of theta when t equals 3 seconds. Okay, so we're going to get t equals 3 seconds. When they asked us to find the maximum angular displacement, one thing we know is that this 0.2 cosine 8 theta t, goodness gracious, can't talk. Cosine is going to return a maximum value of -1 and a minimum value of -1 and a maximum value of +1. So our maximum displacement is going to be 0.2, and then all of this, the biggest thing it can return is 1. So our maximum displacement is going to be 0.2. Now you could probably look at the graph of it and determine that, but you can also just think that this is an easy one to determine. That's going to be the maximum value there because cosine's never going to get bigger than 1 on its own, and then we multiply the 1 by 0.2. Now it's asking us to find the rate of change when t equals 3. Well, the rate of change is another word for the slope, is another word for the derivative. So what we're going to do is take the derivative. Now, if working with these thetas and t's bother you, remember we could rewrite this thing as y equals 0.2 cosine 8x, and it might be easier for you to think about taking the derivative there. If I didn't change the variables out, I would be taking the derivative of theta with respect to t because my variable is t, and then theta is kind of like the y. This is like your dy dx over here. But if I want to change the variables out and work with it just to be more comfortable, I could. And so let's do that just to give you maybe a technique for when things look a little confusing. If I want to take the derivative of this, let's let remember we know we're in this section where they're kind of having us do something called the chain rule. Let's let u equal 8x so we can take this derivative. Remember, when we take the derivative, we're going to actually take the derivative of u with respect to x, whatever we use to substitute for, and the derivative of 8x would just be 8. Okay, so if I want to take this derivative over here, it's going to be let me first of all, let me rewrite the function. That's 0.2 cosine u, okay? So if I want to take the derivative of y with respect to x, it's going to be 0.2 cosine u du, okay? The derivative of this, actually, I'll just put it like this. Okay, so the 0.2 is a constant, it stays out front. Okay, the derivative of cosine is negative sine of u, and then the du dx is going to be, I'm just trying to put a u there, cosine u du dx. The du dx is 8 here, okay? So that's going to be 1.6 out in front. But the u is really not, I'm going to put the negative 1.6 out front, right? And then sine, what is u? Really, it is 8x. I go back, it's like I'm just using that u in a way to treat this like a composite function. And it's also that idea of substitution so that I can work this problem and divide its parts into parts more easily and get through it. So my derivative would be negative 1.6 sine 8x. Well, our x's in this problem were really t's. So if I want to find what they want to know what's the rate of change. The rate of change is not a function, it's a number. That's going to be sine of 8 times t is 3, so that's sine of 24. Okay, and this is in radians. Okay, so we need to make sure we put our calculator in radians. And when you do, you get about 1.4489 if you punch that in the calculator. I'll write the answer in blue. You punch that all in and run all the numbers. It's 1.4889 rounded to 4 decimal places radians per second. So I'll just put rad per second. So when you see rate of change, it's telling you to take the derivative. And since we want the derivative when t is 3, or the rate of change when t is 3, we'll just plug in 3 for t. Again, I could have done all that. Without changing the variable, but if I start, what I would have had to say is d theta over dt is 0.2 cosine u du d theta, okay? And so that starts getting kind of confusing. I'm just trying to show you that this is not any different from anything you've been doing. They just messing with the way the variables look, okay? Okay, 120 and 121 are true and false. I just thought I'd run through them since usually everybody's scared of the ones that have the big numbers on them. There's nothing really scary about this, though. If y is 1 minus x to the 1/2, then have they taken the derivative correctly? Okay, well, let's see. Let's run through it really quickly. If we let u equal 1 minus x, we know we're going to need the derivative in a minute, so I'm going to go ahead and take it. That would be the derivative of 1 is 0. The derivative of negative 1x is just negative 1. Okay? So now, if I want to take the derivative, let me rewrite the function first. I keep trying to take the derivative without rewriting the function. This is just u to the 1/2 power. If I do the derivative, it's going to be drop the 1/2 out front. It's u, and then if I subtract 1 from the exponent, 1/2 minus 2 over 2 would be negative 1 over 2. And then I need the du dx. Well, I know what the du dx is. I kind of had done that, remember, before we got started. So that's 1/2 u to the 1/2, negative 1/2. Let me go ahead and put the u in. The u is 1 minus x to the negative 1/2. And then the du dx was just a negative 1. Okay, so if we take, that means that negative 1, I could put it out front. It's negative 1/2, 1 minus x to the negative 1/2. Now, if you compare that with what they asked in the question, the only thing wrong with it is they didn't get the right sign out front. So this would be false just because they didn't get the right sign out front. This is another true or false question, and we're just trying to see did they take the derivative correctly. So let's do this. Let's start with our function. Let's let u be 2x. Okay, so du dx is just going to be 2. So what I really have here, I'm just going to write y. I'm going to rewrite the function. That's sine u squared, right? And then du dx. Okay. Now, if I take the derivative of this, I got to use the chain rule again because now I need to, let's pick another variable. Ooh, this is going to get confusing. Let's let v equal sine u. The derivative of v is going to be negative cosine u, right? So here's the deal. I kind of got to use the chain rule twice. I'm going to say, okay, so sine, if I back up, let's start from here, okay? If I've let y equal sine u, we call that v. That's going to be v squared. I need to multiply it by du dx, but I also now, because I've got a new variable, I also need to multiply it by dv dx. Because I just kind of got to keep going. I can keep up with all this and do it all at one time. Alright, I rewrote it. Now let's take the derivative. Actually, this du dx, dv dx goes down here. I'm sorry. If I rewrite the function, it's just, it would be v squared du dx. I'm actually just rewriting this function here. Okay, so that would be 2v and to the 2 minus 1. I need to multiply it by du dx because that was part of the function here, but then I introduced another variable, so I need dv, actually that's dv du. I shouldn't have put dx. The variable is a u, isn't it? Okay, that's 2v. Well, my v was really sine u. I'll go ahead and substitute as I do this. dy dx, if I back up, I'm sorry, that was du dx, was 2. That was right over here. And dv dx was right here, negative cosine u. And what was u? U was 2x. Okay, so let's see what we got here. I'm going to write in a different color just because it's getting squished in here. Y prime would be 2 times 2 would be 4. sine u, well, what was u? It was 2x. Okay, so there's our sine 2x. I did that too and that too. And then I've got negative cosine. So let's multiply negative cosine to x, which I'd already plugged that part in. If you compare that to on the true-false part there, they've got 2. Okay, I've got a negative 4 out front. They've got a 2 out front. Sine 2x, cosine 2x. I'm getting. I'm going to check my answer with the key. Oh, they just split it up. It is still false because the sign is different. They took that 4, if you look at the answer key, and they split it up, and they put 2 of the 4 here and 2 of the 4 here. But there should have been a negative that got moved out front, and it didn't. This would match the answer key. This would match what we wanted up here that I'm circling, except that we got a negative on it. So the answer here, and this does agree with the answer key, the answer is false because that negative is messing it up. It would come out to be that, except there's a negative there that came in when we took the derivative of sine here. Derivative of sine is negative cosine. That's where the negative got introduced, and so this is also a false answer here. So it was true, false, but anyway.